Hello, welcome back to Following Science, the podcast where I delve into the latest scientific discoveries and the incredible minds behind them. I'm your host, Rutu Ruparel, and today I'm going to be embarking on a fascinating journey with you guys to the edge of the periodic table, where scientists are pushing the boundaries of what we know about the universe. Now, imagine being on the frontier of discovery, where every experiment could lead to the uncovering of something that the world has never seen before. This is the reality for scientists at Lawrence Berkeley National Laboratory, who are on a quest to create the heaviest element ever known, element 120. Recently, this team made a groundbreaking achievement by synthesizing livermorium, element 116, using a beam of charged titanium atoms. This might sound like science fiction, but it's very real and it's very challenging to do. Now, creating super heavy elements is no easy task. The heavier the elements, the more unstable they become. Now, this instability means that they break down quickly, making them difficult to study. This experiment that created livermorium involved smashing a beam of charged titanium atoms into a piece of plutonium. This process required millions of trillions of collisions just to produce a few atoms of livermorium. But why titanium? Titanium has never been used in such experiments because it's incredibly tricky to turn into a well-controlled beam. The researchers started with the rare isotopes of titanium, which they then vaporized in a special oven at 1,650 degrees Celsius. That's about 3,000 degrees Fahrenheit. Now, using microwaves, they then transformed this hot vapor into a charged beam, which was then fed into a particle accelerator. When this beam collided with the plutonium target at 10% of the speed of light, the resulting debris revealed signatures of exactly 2 atoms of livermorium. Now, this experiment presented at the Nuclear Structure 2024 conference wasn't just about creating livermorium. It was a crucial step forward towards synthesizing the elusive element 120, also known as unbillium. Now, scientists believed that a titanium beam will be essential for this future experiment because, according to Michael at Michigan State University, this groundwork is necessary for moving forward. Now, the creation of element 120 isn't just about adding another block to the periodic table. It has profound implications for our understanding of the strong force, which determines the stability of heavy elements. By studying element 120, scientists hope to gain insights into how exotic elements may have formed in the early universe. Now, the heaviest made element so far is oganesson, element 118, which was first synthesized in 2002. The journey to create even heavier elements has been fraught with challenges because it requires smashing together very heavy elements, which are often unstable themselves. However, recent successes with titanium beams, of course, make the researchers at Berkeley Lab very optimistic about being able to achieve element 120. Now, in 2025, they plan to start experiments aimed at creating element 120 by replacing the plutonium target with the heavier element californium. This advancement is expected to bring us even closer to putting a new element on the periodic table, a feat that few scientists ever get the chance to achieve. Now, what's particularly exciting about elements 119 and 120 is that they belong to a new row of the periodic table, the 8th period. This means that they will have a unique electron configuration or orbital that scientists have never observed before. These new configurations could lead to entirely new chemical properties and reactions. Now, creating new elements involves using particle accelerators to collide beams of ions with atoms in solid targets. And this is done to induce nuclear reactions that produce elements with more protons and neutrons. Now, the recent experiment with livermorium shows that heavier beams like titanium can succeed where lighter beams like calcium have reached their limits. Now, Yuri Oganesyan, a prominent figure in the field and a namesake of element 118, Oganesson, emphasizes that each step forward in this research is vital. His team has also been experimenting with titanium and chromium beams to find new ways to create super heavy elements. In October 2023, they reported previously producing an unseen isotope of livermorium using a chromium beam, showing another potential path to element 120. Now, theoretical models in this area are still developing, because different models predict different optimal energies for producing super heavy elements, and each experiment provides valuable data to refine these models. Now, as scientists narrow down the best experimental parameters, they edge closer to their ultimate goal. Now, the path to creating element 120 is long and arduous. Gates and our team at Berkeley estimate that they will need 100 to 200 days of runtime, bombarding California with titanium to have a chance at producing element 120. This translates to about 2 to 3 years of dedicated research. Now, Oganessian suggests that it could take 6 years of continuous effort, but preparatory experiments like those at Berkeley and his lab are essential for reducing this time. Now, the journey to synthesize the heaviest element known to man and known to humanity is a testament to human curiosity and perseverance. Each experiment, each collision brings us a step closer to understanding the fundamental forces that shape our universe. And so the quest for element 120 continues. It's a story of precision, patience, and the relentless pursuit of knowledge. As researchers around the world collaborate and innovate, we can only imagine what new discoveries await us at the frontier of the periodic table. Now, as I wrap up this episode, I just want to thank you all for joining me on this episode of Following Science. Now, I know this episode was on the shorter side, but I hope it gave you a glimpse into the incredible efforts and cutting-edge research involved in the quest for element 120. It's research that's ongoing and important right now. Anyways, thank you again for joining me on this episode of Following Science. Stay curious and stay inspired. And of course, don't forget to subscribe to my podcast for more fascinating journeys into the world of science. Until next time, keep exploring the wonders of the universe. I'm your host, Rutu Ruparel, and this has been Following Science.